Hi everyone, this is Physics 6B, Homework 3, Question Q3. And what this question is that two out-of-phase speakers are positioned 4 meters apart, both pointing toward a wall, square root of 7 meters in front of them. A listener positioned at the wall midway between the speakers hears virtually nothing, which is perfect destructive interference. When he moves to the side by 1 meter, he hears a large sound, which is max constructive interference. What is the frequency of the sound emitted by the speakers? Take the speed of sound to be 360 meters per second. So what this question is saying that there's a person against the wall, two speakers that are square root of 7 meters away from him, and the speakers are 4 meters apart. And if he or she moves 1 meter, they'll have a perfect constructive, max constructive interference. And right now where they're standing, it's destructive interference. So let's start this problem off by writing the formulas we'll use. So I know from our equation sheet we use phi equals 2 pi delta r over lambda plus delta phi naught. And we also use this one, delta phi equals m plus 1/2 2 pi, and delta phi equals m times 2 pi. This one's for destructive, and this one's for constructive. Alright, so what we can do for first is write our knowns and unknowns. We know that this is 4 meters, we know that it's 7 meters, we know that that's 1 meters, we know speed of sound is 360, we're trying to find lambda, and we're trying to find frequency. It's a two-step problem because d equals rt and that equals v equals lambda f. So we need to find lambda and frequency to solve this problem. And we know how to find lambda from here. So let's get started. Let's do destructive first to prove that our initial phase is 0. So we can put these two equations together. 2 pi delta r over lambda plus naught equals m 1/2 plus 1/2 2 pi. We know that m equals 0 because it's the initial phase, and delta r is currently 0 because we didn't move anywhere. So this whole part cancels out. We know that this is pi. We know this is 0 plus 1/2, so 1/2 times 2 pi. The 2's cancel out. Pi equals pi. This is for destructive. Pi equals pi. And let's do constructive now. So constructive would be delta phi equals 2 pi delta r over lambda plus phi naught equals m times 2 pi. So I know this is 0, so this is going to cancel out. We actually can't do this problem yet because we need to figure out r. Alright, so we need to figure out r. And what we know to figure out r is our triangles. So if the person moves 1 meter to their whatever side, left or right, doesn't matter, the triangle will look like that. So this is 7, square root of 7. This is still 4 meters total. This side will be 3 meters, this side will be 1 meters. Let's just call this R1 and R2. So how do we solve for triangles? We know a squared plus b squared equals c squared. And what we can do from here is R1 equals a squared, which would be 3 squared plus b2 side 2, which would be square root of 7 squared equals c squared. Or we could just put that all under the box to get rid of the squares. So that would be 9 plus 7 equals square root of 16. And R1 equals 4. Alright, now we have to solve for R2. Equals 1 squared plus square root of 7 squared equals c squared. So what we do here is 1 plus square root of 7. All of that under that. And that will equals 8 square root of 8. R2 equals square root of 8, which also equals square root of 8 equals 2.8. 2.8. So we're looking for delta R. So 4 minus 2.8 equals 1.2 meters apart. So let's plug that back in. 2 pi times 1.2 meters over wavelength plus, oops, I didn't write that earlier, plus pi, because we knew that was pi from earlier, equals 0. What do we do from here? We simplify to find wavelength. So let's move this to the other side first. Alright, so we know this. And to move this to the other side, we have pi equals 2 pi 1/2, or 1.2 over wavelength equals pi. Let's cancel out some of the pi's. So let's cancel out the pi's. So now we have 2 times 1.2 over wavelength equals 0. Let's move wavelength to that side. So 2 times 1.2 equals wavelength. And 2 times 1.2 would be 4 or 2.4 equals wavelength. Alright, so we found wavelength now. Now let's plug that in back into our D equals RT. So from here, D equals RT is also equal to V equals lambda frequency, because we're looking for frequency. We finally have wavelength. So 2.4 F equals velocity, and we have our velocity from our 360 meters per second. So we have 360 equals 2.4 F. What we can do now is 360 divided by 2.4 equals F. So what's 360 divided by 2.4? Equals 150 hertz. F equals 150 hertz. Alright, sorry about the mess. It was actually really hard writing on paper while recording because the paper was moving side to side the whole time. And I can't really see if I'm holding the phone recording, so I'm just going to explain my whole process again. So we start with our 3 equations that we know. The regular one, phi naught equals 2 pi r delta r over wavelength plus phi naught. Destructive interference, which would be delta phi, equals m plus 1/2 times 2 pi, and then constructive, which is delta phi, equals m times 2 pi. So we take that and we simplify it down for these constructive interference. So we cancel out the we plug in 0 for m because we know that m was 0 because of the initial phase. We simplify the 2 and the 2, so that leaves us with pi on the right hand side. We know that this is pi from right here. This is pi, we know that. And then the change in r was 0 because initially the person didn't move yet. So that's 0 and it cancels out that whole thing. So we know pi equals pi. So we try to do that for constructive. You can see here m is 0 times 2 pi. That just equals 0. And then we have the rest of the equation, and we're looking for delta r before we can continue. So we calculate a squared plus b squared equals c squared. We calculate the square root of 9 plus 7 equals square root of 16. R1 equals 4, which is essentially the side right here. That equals 4 meters. And then we do the same thing for the triangle over here. As you can see, I'm pointing to R2. This equals 2.8. And we do the change in R, which is R1 minus R2, which is 4 minus 2.8, which is 1.2 meters. We can plug that in for our change in R, as you can see here. After plugging that in, what did I do? I moved the pi over so we could cancel out the pi's to find, or to isolate lambda. That's what I did here. As you can see, 2 times 1.2 equals lambda. And the units for this is in meters. Sorry about that. 2.4 meters. And we use d equals rt. Velocity equals wavelength frequency. 360 equals 2.4 f. 360 divided by 2.4 equals f. And our frequency is 150 hertz. And that's what the question was originally asking. What is the frequency of the sound emitted by the speakers? There we go, 150 hertz. Thank you.